So today, uh, in physical chemistry, in the group theory, the last lecture in which we will discuss about the previous concept that we have discussed. Just like these are some important table or important terms that we need to remember. So some of them are as follows. Just like first, the number of classes is equal to number of Mulliken symbol and number of irreducible representation. So this is also the second one is the number of IR, the number 2 IR has same values. मतलब no two irreducible representation have same values. Sum and square of character of any IR is equal to order. And fourth, the sum and square of any IR is equal to order. And the fifth one is the great orthogonality theorem or the great orthogonality condition, which is summation of IR1 and IR second, irreducible representation of first and second is equal to 0. So these are all the terms which is important, or this is psi matlab xc is equal to h order, and x is always 1 for A, 1 for AB, and 2 for E, and 3 for J, as we have discussed in our previous this rule section. So now let's talk about the formation of first column. So xe1, if the value of xe1 1 is present in E, then in character table xc position 1 is present, then A and B is used, and in second position E is used, and in third position T is used if 3 is given. And these are all the rules that we have discussed in previous chapter. So now let's discuss some questions which can be asked. So the first question that is asked in 2024 is the order and the number of classes present in a group with the irreducible representation, and that is given. This is A1 and A2, B1, B2, E1, E2 are respectively. So as we have known, the sum and square of identity is equal to order. So the value of A, according to this rule, A 1 and A2 is also 1, B2 is 1 and B2 is also 1, and E is present, then we use, if E is present, then we use 2. So it is 2 and 2. So we put all these values and multiply and sum and square according to this formula. 1 square plus 1 square plus 1 square plus 1 square plus 2 square plus 2 square is equal to h. So solving this, we will get 14, which is the order. So we will get the order which is given first 12. So this cannot be, this cannot be. And number of classes. So number of classes can be easily counted. So 1, 2, 3, 4, 5, 6. 6 classes are present. So this is the final answer. Now let's get back to the next question, which is this. Determine the table character table of point group D8 is given, and the value of A, B, C, D, E, F, G, H, I, J, and K. So these are all the empty places which is present, just like this I, H. So these are all the empty places which are given in this character table. We need to find them. So by using different methods or the formulas that we have discussed in the previous slide. So using great orthogonality theorem, psi is equal to 1 IR1 plus IR sec 3. If you put this 1 and this 3, then we will get 0. So putting all the values, we will get the final answer is 0, or this is the method, as you can see given. The values will be 1 1 1 1 1 2 2 2. Now for the another question, for a given point group, an incomplete character table is given below, which are the IR are missing. So we need to calculate these empty points which is given in this character table. So how do we calculate this? So we know that the sum and square of any character is equal to order. So we know it's we know 1 square plus b square, which is 1 square. We can know that 1 is also present here. By so 1 square plus b square is equal to 6. So by putting these values, we will get the final answer of this b1 111 minus 1 will be the final answer. Let's dive back to the next question, which is asked in grade 2021. The character of E1, C1, sigma v and sigma v dash symmetry operation in this order for value IR1 of the C2v and PT group is or are. So in this question, we need to find out about the point group or the values of this symmetry operation. So we know that the value of E cannot be negative, so this is not possible. And we also know that these 3 negatives are present here, so it is also not possible. So these two are the only possible terms that can be given in this point group. Now, and for the next question, the part of the character table of a point group of order 4 is given below. So this is the order of the point group that is given below, and the 4 character of this irreducible representation of 4 are respectively. So irreducible representation, we need to calculate the IRS. So putting the values first, we will get the sum and square order by putting this formula. We will get the A1 value is 4. Now let's discuss about the last topic, which is application of character table. So here we will be calculating about the irreducible representation and their method of calculation it. After that, we will be discussing about the vibrational modes and the IR and Raman activities which can be performed, and last will be the electronic transitions. So for calculation of irreducible representation, we use this formula. This is the formula that we use for calculation irreducible representation. This formula, which is very important, according to which number of irreducible representation is equal to 1 upon order summation of IR1 or the irreducible representation into IR from character table, psi RS from character table into number of operations corresponding to this particular symmetry. So these are the technical words. What it means is that, let's take an example. So the irreducible representation in the character table is equal to following separation of the irreducible representation of the C2V point group. So this is given. We need to calculate its reducible representation. So for calculation of reducible representation, we use this formula as we have seen previous. So it is equal to 1 upon H summation of XR reducible representation into summation of IR or XR into number of symmetry operations that is performed. So these are the symmetry operations, the values which is given in front of these. So here we know that order is 4. Why 4? Because 4 operations are present and no values are present in between them. So 4 symmetry operations are given. 4 is the order. And now number of A1. So we need to calculate first the A1. What is A1? A1 means this reducible representation. So to calculate its irreducible representation of A1, we use the formula 1 upon order summation of 8. Why? What is 8? 8 is the reducible representation which is given. We need to calculate the irreducible representation. So 8 into 1. What is 1? 1 is the value which is given in A1 and or E, plus into 1. Why it is 1? 1 is also here. E1 or C1. This is also 1. This is also 1. So plus this is for the first value. Now if we get to the next value, which is C2, and again for sigma v and sigma v dash. So these are all the values that we have put here. So by solving this, we will get the number of A1 is equal to 1. Okay. Then for the calculation of A2, the same we put 1 upon order, which is into 8, which is character table reducible representation into 1 into 1, which is the values, and by solving this we will get the value 2 for A2, and we will get the value for B1, it is 4, oh no, for 0, and for the number of B2, this is B1, this is B2, so number of B2 it will be 5. So the total irreducible representation will be A1 plus 2A2 plus B1, which is what is B1, so it is 0, so we calculate 1, so B1 is present, plus 5 B2. Now for the next question, let's discuss about the character table of C2V point group. It is given to provide below, along with an irreducible representation. So this reducible representation is also given for this point group. So this 602 is given. So we need to calculate the irreducible representation. So as we can see, if 0 is present, then we do not calculate this. So A2 will be not present. In the previous here, this B2 will be not calculated. Okay. Now let's discuss about the formula that we have discussed, which is 1 upon order. In this case it is 6. Why 6? Because 3 sigma v's are present, 2 sigma c3s are present, and 1 identity. So by adding all these 3 to 1, we will get 6. 6 will be the order here. Now if we add all these values, means 6 into 1 into 1, 1 into 1, we will get 6, and 0 से multiply करेंगे anything, that will be 0, and for again 2 into 3 into 1, so it is 6. So 2 will be values for A1, 0 for A2, and for identity it will be 2. So the irreducible representation can be A1, so 2A1 and 2E. So this is the final answer. Given the character table of the point group C3V, A1, A2, E, the values are given here. So we need to calculate its irreducible representation again. So for calculation irreducible representation, we use the formula 1 upon order into, and putting all this value, we will get A1 2 and A2 2, and E it will be 1, and this is the final answer, 1E1, 2A2, 2A1. So this is the E, 1E, 2A1 and 2A2. So this is the final answer. Now let's discuss about the second application, which is calculation of vibrational modes. So with the help of this we will find out about vibrational modes. So in general, in physical chemistry, we use this vibrational modes such as linear molecule and for non-linear molecule. So these are the formula, 3n minus 6 for non-linear molecule, and for linear molecule it will be 3n minus 5. So this is the general formula for calculation of number of, where n represent number of atoms. Let's take an example of pyridine. So we need to calculate the vibrational mode which is present in pyridine. So the formula will be 3n minus 6. Why 6? Because it is a non-linear molecule. So by putting the value of 6 here, we will finally get the answer 27. So these are the total number of vibrational modes present in pyridine molecule. This is the total number of vibrational present in molecule. So according to total number of modes, which are translational, rotational and vibrational, all the 3 types of modes are present in vibration mode on this total number of irreducible representations. And this is important. Why? Because it tells us about the total number of irreducible representation, or the total number is equal to translational plus rotational plus vibrational mode. So all these values combine to form the total number of IRs. So, and the third application, which will be the IR and Raman activities. How do we find this? If a compound or if the character table, just like here, as you can see in this question, the total number of IR active vibrational mode of pyridine is. This is the question. So vibrational modes can be easily seen by, if IR active vibrational mode, those which has x and y and z coordinates. So if A1 has this z coordinates, then this is active and this is IR active. And if what is Raman activity, those molecules, those modes are Raman active in which quadratic equations are present. So this quadratic equations which is given in the calculator table are Raman active. And if this is IR, this do not have any xyz coordinate, so it is IR inactive. Again this has it, and this and this has it. So total number of vibrational mode can be calculated by. So for calculation this, we first need to calculate the reducible representation of the molecule. So we know that it is the structure of pyridine. So we know that it has n equal to 11 number of atoms present. This 1 2 3 4 5 6 7 8 9 10 and 11. These are all the atoms present here. N is equal to 11 and its order will be 4. Why? Because this is 1 2 3 and 4, as we can see calculating this. And we will get the reducible representation. How do we get this? Just like that, for C2V point to group, number of unshifted atoms, so the 11 unshifted atom when we put E identity, and after passing C2, just like from all the way from middle, number of unshifted atom will be 1 2 and 3, so 3 will be present here. After putting sigma xz, one plane horizontal, so it is a sigma horizontal, so 11, all the molecules are unshifted. And after putting a vertical plane, 3 molecules are unshifted. So and putting the values of CPA, Cartesian values, which we have discussed in previous lectures. So we will get the reducible representation of 33 minus 3 11 and 3. After that we need to calculate the irreducible representation, which is the second step. This is the second step. So calculating the reducible representation is the first step, and for calculating the second step we will use the formula 1 upon order into x character of the molecule into this 1 into 1 into the reducible representation, which is 33. So these are the formula that we use, and we will get the value for A1 will be 11, for A2 it will be 4, for B1 equal to 11, and for B2 equal to 7. After that we will get all the total number of reducible representations. So these are total number of reducible representation, which is 11 plus 4 plus 11 plus 7. All these are in this irreducible representation. We will get the translational plus vibrational plus rotational. So for identifying the vibrational, we will check the total number of irreducible representation minus translational plus rotational. So for calculating the putting all the values, these are the total number of IR, which are this, minus the translational plus rotational. How do we calculate this? By checking into these values. So these are the translational, this z, x and y axis, these are translational. So by putting the values here, we will get the final the final vibrational modes, which are 11 not the vibrational modes, 11 A1 plus 3 A2 plus 9 B1 plus 5 B2, and IR active vibrational modes will be equal to 10 A1 plus 9 B1 plus 5 B2. Why? Because 3 A2 there are no IR, so 3 A2 these are IR inactive. because in the character table it do not have x, y, z coordinates, and the total number of IR active coordinates are, by adding the 10 plus 9 plus 5, so we will get 24. So this is the final answer that we will be getting by solving this question. Now let's talk about the fourth application, which is electronic transition. So how do we find out if the molecule has electronic transition or not? So there are allowed transition. Those transitions which are allowed uh, are, if we check the IR1 and IR2, product of both ground state, excited state lies in character table, then it is allowed transition. And the second will be, the corresponding to it x, y, z coordinate must be present. So it has to be lies, and x, y, z coordinate corresponding to that will also be present in the character table. Then only the molecule will said to be electronic transition is present. So here, as you can see for the example, so this is example. So according to this, for H2O molecule, the electronic transition for the ground state of an ground state on excited state of B1 symmetry is. So we need to check this A1 and B1 will give the electronic transition are possible or not. So we need to check this, that just that. So A1 will be this and B1 will be this. So by multiplying these two, 1 into 1 1, 1 into minus 1 minus 1, 1 into 1 1, 1 into minus 1 minus 1. So this value must be present in the character table. So this is the value of B1, 1 minus 1 and minus 1. So corresponding to this value, x, y, z coordinate must be present. So this x coordinate is present. So x coordinate is present, so it is allowed transition. And according to answer, this is allowed with x polarization because x coordinate are present here. So B will be the right answer here. These are some, also you can check the examples. Thank you.